Hi folks, I'm sorry that I didn't finish the 20s in all one video. So the last video was pretty much all of the questions on the 20s, and now we are going to go into the next chunk. So we're going to skip through all of this. This is all stuff that's been shown to you already. Now we're on to the back side. And we finished 20, and we finished 21, 22 on the last one, and now we're going to be on 23 for this problem. So in this problem, it wants to know how many grams of lead nitrate would be used in to make 50 milliliters of 0.00200 molar lead nitrate. So we are starting, didn't mean it to do that. Having a little bit of a technical issue here. All right, now hopefully we're back on track. We're going to go from here to here to here to here. That is our plan. So we're going to start with the 50 milliliters of PbNO3 solution. That seems like a big label. Sorry, but get used to it. All right, and then we're going to have milliliters of PbNO3 solution. And if you're on milliliter island, the only place that you're going to be able to go is to liter island. At this point in time, we have not taught you how to go to gram island. So that's going to be liters of PbNO3 solution. We don't want our answer in liters, we want our answer in grams, so multiplication sign, division bar. Liters of PbNO3 solution. So right now we're right here. It would not make any sense to go back to milliliters, so we're going to go up 2 moles. So we can write moles of PbNO3 2. Multiplication sign. And I'm going to have to finish this one over here. So we don't want our answer in moles of lead 2 nitrate. We want our answer in grams of lead 2 nitrate. So moles, PbNO3 2 go on the bottom, and grams of PbNO3 2 go on top. Now we have to pop some numbers in. Milliliters, this part right here, milliliters to liters. So we're going from here to here. This bridge is 1,000. So there are 1,000 milliliters in every liter. Now we're going to go from here up to here. This bridge is mole per liter bridge. So we're going to use the molarity that they give us in the problem right here. That is 0.00200 moles in 1 liter of solution. And then lastly, we are going to go from mole island over to gram island, and we always use the periodic table or molar mass. So when we look up this problem, we find out that there are 331.22 grams in 1 mole. We crunch all of that data, and we end up getting an answer of 0.0313 grams of PbNO3 or lead 2 nitrate. Okay. Now, let's describe how we're going to make that. So we can go up to question 21. It kind of has the entire setup. But in this case, we would get a 50 milliliter volumetric flask. 2, we would fill that volumetric flask half full of water. 3, we would add 0.0313 grams of lead 2 nitrate. We would swirl, number 4, we would swirl that until all of that has dissolved. Number 5, we would fill the volumetric flask to the line with water. And then number 6, we would cap and invert the flask until homogeneous, which is about 12 times. So that's how we would go about making that particular solution. All right, question 25 is an interesting question. It wants to know if you took 250 milliliters of a 5.64 molar solution and add an additional 500 mils of water to it, what would be the new molarity? Again, remember, it's moles over liters. So what we're going to do is we're going to find out how many moles we have here, and then we're going to put that over our new liters, and that's going to tell us our molarity. So what we're going to do is we're going to start off with 250.0 milliliters of solution. So we're starting off right there on our sheet. We're going to go right here, and then we're going to finally end up there. So that's milliliters of solution. We put milliliters of solution on the bottom. We put liters of solution on top. You don't want to answer liters, we want it in moles. So liters solution, and then moles solution. Excuse me, actually moles of solute, not moles of solution. All right, so now we go back and we put in some numbers. So when we go from milliliters to liters, this is 1,000 right there. So that would be 1,000 milliliters in 1 liter. And when we do this part right here, which is moles over liters, that's going between these two, and we use the molarity that they give us in the problem. So that is 5.64 moles in 1 liter. We solve all that, and we end up getting 1.41 moles of solute for this problem. Now that's only one little bit of information that we need. So again, molarity is moles over liters. So now we have 1.41 moles. Now, how many liters of total solution do we have? We started with 250 milliliters. We added 500. So that is 750 milliliters. But we don't want it in milliliters, we want it in liters. So, there's two ways you can do it. You can go through the factor label problem of converting milliliters to liters. So 750 milliliters. And there's 1,000 milliliters in 1 liter, and get your answer of 0.750 liters. Or if you're capable of doing it in your head, you can always do it in your head. That is fine. You solve that problem, and you find out that you have a 1.88 molar solution. So if you started with a 5.64 molar solution and you add more water to it, it should become more dilute, and that answer does in fact give us a more dilute answer. Question 26 is slightly different from the one before it. You have 45 milliliters of 5.64 molar solution, and it's placed into a 500 milliliter volumetric flask and diluted to the line. So again, molarity is moles over liters. So again, we're going to start with 45.0 milliliters of solution. Milliliters of solution. And the only place you can go from milliliter island is to liter island of solution. We don't want our answer in liters, we want our answer in moles. So liters of solution, and over the top of that would be moles of solute. So to get this information right here, there's always 1,000 milliliters in 1 liter. And when we get information here, it is molarity. So that is where that number comes in. 5.64 moles in 1 liter of solution. You solve that and you get 0.254 moles of solute. So look that over, pause it if you need to. I'm going to erase some stuff so I got a little bit more room to work. So again, molarity is moles over liters. So now we have our moles, 0.254 moles of solute. And now we need our liters. Well, we're putting all of this solution into a 500 milliliter volumetric flask. That means the ending volume is going to be 500 milliliters. 500 milliliters you can convert, so 500 milliliters to liters, 1,000 milliliters in 1 liter, and you can get 0.500 liters. Or if you can do that in your head, that is fine. So you go 0.500 liters, and you solve that. When you solve that, you end up getting an answer of 0.508 molar. So again, you started with 5.64 molar, you added some water to it, and you end up getting a less concentrated solution or lower molarity solution. Hopefully that helped, folks. Go back and watch it again if you need to. Come in if you need some help.